Flight dynamics is the study of the performance, stability, and control of vehicles flying through the air or in outer space. It is concerned with how forces acting on the vehicle influence its speed and attitude with respect to time. Aircraft. This section focuses on fixed-wing aircraft. For other kinds, see aircraft. Flight dynamics is the science of air vehicle orientation and control in 3 dimensions. The 3 critical flight dynamics parameters are the angles of rotation in 3 dimensions about the vehicle's center of mass, known as roll, pitch and yaw. Aircraft engineers develop control systems for a vehicle's orientation about our center of mass. The control systems include actuators, which exert forces in various directions, and generate rotational forces or moments about the center of gravity of the aircraft, and thus rotate the aircraft in pitch, roll, or yaw. For example, a pitching moment is a vertical force applied at a distance forward or aft from the center of gravity of the aircraft, causing the aircraft to pitch up or down. Roll, pitch and yaw refer, in this context, to rotations about the respective axis starting from a defined equilibrium state. The equilibrium roll angle is known as wings level or zero bank angle, equivalent to a level heeling angle on a ship. Yaw is known as heading. A fixed-wing aircraft increases or decreases the lift generated by the wings when it pitches nose up or down by increasing or decreasing the angle of attack. The roll angle is also known as bank angle on a fixed-wing aircraft, which usually banks to change the horizontal direction of flight. An aircraft is usually streamlined from nose to tail to reduce drag, making it typically advantageous to keep the side slip angle near zero, though there are instances when an aircraft may be deliberately side slipped, for example a slip in a fixed-wing aircraft. Spacecraft and satellites. The forces acting on spacecraft are of 3 types: propulsive force, gravitational force exerted by the Earth and other celestial bodies, and aerodynamic lift and drag. The vehicle's attitude must be taken into account because of its effect on the aerodynamic and propulsive forces. There are other reasons, unrelated to flight dynamics, for controlling the vehicle's attitude in non-powered flight. The flight dynamics of spacecraft differ from those of aircraft in that the aerodynamic forces are a very small, or vanishingly small effect for most of the vehicle's flight, and cannot be used for attitude control during that time. Also, most of a spacecraft's flight time is usually unpowered, leaving gravity as the dominant force. References.